So in day 15, we continue to use formulas that involve exponential growth. The two that you see on the screen are regular compoundings and continuous compoundings, and both of these are applied to money. And the difference is if your interest is compounded, say monthly or daily or every hour or every quarter, you're going to use the regular compoundings formula, which has an N in 2 spots. If you're told that the money compounds continuously, that means that every fraction of a second you get interest, and that formula is a lot easier to work with, and this is by far the more common way that money is earned in an interest account. So we're going to learn to do both, but the second case is the easier one, and it's by far more common. So first example, calculate the amount in an account if you invest $2,000 at 2% interest compounded monthly for 4 years. So what all these letters mean? P is the initial deposit amount. So in this question, P is 2,000 right there. Okay. R is the rate of growth, but it needs to be a decimal. So when they say 2%, I'm going to change that 2% into 0.02 and plug it in for R right here, 0.02. N is the number of compoundings, and sometimes it's not a number, they'll give it to you as a word. So when it says compounded monthly, that means 12 times in a year. So the N in 2 spots becomes a 12. And then lastly, T, the input, is the amount of time that you're letting your money earn interest. So T in this example is 4 years. I changed the T to 4. So the one thing I don't know is the amount in my account. That's the output, or the A. So now that I've changed all of these letters into their appropriate numbers, order of operations says you do 0.02 divided by 12 and add 1. You get 1.0016 repeating. Next is the exponent. 12 times 4 is 48. When I take 1.0016 repeating raised to the 48, I get 1.08, and that number there means that I'm getting about 8% earnings. 1.08 times 2,000 gives me 2166.43. So for each of these long decimals, you got to learn how to use the memories in your calculator. Store these numbers in the memories and don't round until the very end because you don't want to be off even by a penny. So the second example says repeat if the interest is compounded continuously. I'm going to switch to this formula. All of these letters are exactly the same. R is the interest rate as a decimal, T is the amount of time, E is a button on your calculator, and P is the initial deposit of 2,000. So when I take and figure out that the exponent is 0.08, I'm going to find E to the power, which is on the left edge above the natural log button. Take E to the 0.08, get 1.08, which means my growth in this example is very similar to my growth in that example. And when I multiply that by 2,000, I get 2166.57. So if you notice, when it was compounded monthly, I had 2166 and 43 cents. When it was compounded continuously, I had 2166 and 57 cents. The only difference by increasing the amount of time or the amount of compoundings to a continuous situation is roughly 14 cents. So the second set of examples involve doubling your money. A lot of times you'd like to estimate how long it's going to take for you to double the amount of money in your account. And when you do regular compoundings, the doubling formula is a little bit complex because there's so many variables. More common is to figure out how long it takes an amount to double in a continuous situation. So if I'm going to double my money, whatever I put in the beginning, P is then going to become 2P. So I've doubled the amount that I started with. Well, if I divide both sides by P, I wind up with this equation, and now I can solve for T. I'm going to change forms. So this is exponential with a variable up here. If I change it into log form, log base E of 2 is RT. And now to solve for T, I'm going to divide both sides by R, and I get T is log base E of 2 over R. Log base E of 2 is the same thing as natural log. So the doubling time is natural log of 2 divided by the rate. And a lot of times you'll see T with a little subscript on it, so I might say T sub 2, which represents doubling time. So because we've done this, if you needed to know how long it takes to triple your money, just take the numbers that you see and modify them for the triple situation. So what happens is when you triple, if you want to know how long it's going to take you to triple your money, replace the 2 from doubling with the 3 for tripling, just like that. So that's it. That's day 15.